Alright, this is 3.2. In this section, we are going to start solving quadratic equations. We're also going to be dealing with quadratic functions and some models. Okay, first thing. So yeah, we're solving quadratic equations. What's a quadratic equation? A quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are any real numbers, and a should not be equal to 0, because if it's equal to 0, then it's not quadratic. Okay, we are going to be solving. So a lot of what we're going to be doing is, setting the quadratic equation equal to 0. In a sense, what we're doing right there is setting our y value equal to 0. What that means is that we're trying to find x-intercepts of the graphs of quadratic expressions. And by the way, up here they tell us that zeros, solutions, x-intercepts, roots, what that means, they all mean the same thing. They all mean the same thing. They're just the solution to a quadratic equation. So if you set it equal to 0. So just kind of keep that in mind. If you're being asked to find the zeros, the solutions, the x-intercepts, or the roots, you're pretty much just dealing with finding, setting a quadratic equal to 0 and finding the solutions. That's what you're doing. There are a few methods of solving quadratic equations. Let's talk about 4 different methods. So here we were given a quadratic equation, x squared minus 12x plus 27 equals 0. I want to find solutions to it. One way to find solutions to it would be to graph the equation. And then since I'm interested in when this y value is equal to 0, well then I'm literally just interested in the x-intercepts. So I could graph the equation and look at the x-intercepts. That would be one way of solving this equation right here. It turns out that the x-intercepts are at 3, 0 and 9, 0. Another way of solving this equation would be to factor. Although sometimes factoring it might be almost near impossible to do, but sometimes it's possible. So factoring, what that means is that originally I have an equation that has on the left-hand side these 3 terms, x squared, negative 12x, and 27. And what I want to do is rewrite those 3 terms as a multiplication. Yeah? Because then what we're going to be taking advantage of, and I'll just mention it over here on the side, it's what's called the zero product property. Zero product property, which says that if A times B equals 0, then A is equal to 0, B is equal to 0, or both. Yeah, so that's what helps us. That's why it's good to factor. So if I manage to express this this difference in sum of terms as a multiplication, then I have that something times something equals 0. Well, then I can set each one of these factors, x minus 3 equal to 0 or x minus 9 equal to 0. And that gives me solutions. So it's factoring takes advantage of this thing called the zero product property. Okay, another method by which we could solve this equation is called completing the square. And here the steps are given to us on how to complete the square. So you begin with your original equation. They subtracted 27 from both sides. And then all of a sudden magically there appears this 36 right here. There's this 36 that all of a sudden appear on both sides of the equation. We added 36. How did we come up with 36? Well, what ended up happening, here I'll fill out some of the details here in a little bubble, is you must have thought negative 12 divided by 2, that's negative 6. So why negative 12 divided by 2? So I looked at this number, negative 12, I divided by 2, that's negative 6. And then I said negative 6 squared, and that gives me positive 36. And what that does is it makes the left-hand side into what's called a perfect square. And on the right-hand side, well, I also have to add 36, because whatever I do to the left-hand side, I have to do to the right-hand side of the equation. So on the left hand side is x squared minus 12x plus 36. Turns out use factors as x minus 6 squared. And then once you have x minus 6 squared equals some other value, we have to take a square root. And do keep in mind that if you take a square root, there is always plus or minus. So if you end up taking a square root, don't forget that you should end up with two values, the plus and minus. So plus or minus square root of 9. And then we add, and so we end up with two solutions. So we have so far talked about three methods of solving this quadratic equation: by first graphing it and looking at the x-intercepts, by factoring, by completing the square, and then there is this thing, the quadratic formula. The quadratic formula works for any quadratic equation. Do not use it for an absolute value equation though. Do not use it for a cubic equation. Do not use it for a linear equation. It only works for an equation of the form ax squared plus bx plus c equals 0. And it gives you the answers of that equation. It gives you the solutions to the equation based on the coefficients a, b, and c. So in order to use the quadratic formula, you definitely first need to start off with your quadratic equation in the form ax squared plus bx plus c equals 0. Okay, so if I wanted to solve this quadratic equation that was given to us, x squared minus 12x plus 27, using the quadratic formula, I would say that my a is 1, my b is negative 12, and my c is 27. And then I would plug those values into my quadratic formula, just being careful to pay attention to my signs. So for instance, my b is negative 12, so I'm going to say negative 12 plus minus negative 12 squared minus 4 times 1 times 27 over 2 times 1. Then you gotta just be careful with your arithmetic and your order of operations here. The first thing you're gonna have to take care of is the thing inside of the square root. So you first wanna kind of simplify the square root as much as possible. Turns out it ends up with 6, and now you have 12 plus or minus 6 over 2. Well, that's two things. That's 12 plus 6 over 2 and 12 minus 6 over 2, and we end up with 9 and 3. Okay, so there are these four methods of solving quadratic equations. Are there more than 4 methods to solve quadratic equations? I think there are, but I'll let you think about those on your own. All right, now there's a special value. Whenever you're using the quadratic formula, anytime that you're using the quadratic formula, this thing inside, the b squared minus 4ac, that's called the discriminant. That's called the discriminant. b squared minus 4ac, that's our discriminant. And depending, so it turns out, so down here they tell us a little bit about the discriminant. So if it's equal to 0, if my discriminant happens to be exactly equal to 0, then I only have one solution. My quadratic equation has only one solution. If my discriminant is positive, then I'm going to have two real number solutions. And if my discriminant happens to be negative, then I'm going to have complex number solutions, and they're going to be complex conjugates. So sometimes you might not necessarily need to know what the solution to the quadratic equation is. All you want to know is what type of solution are you going to have. Are you going to have a complex pair conjugate solution? Are you going to have a real pair solution? Or are you just going to have a single real solution? Okay, so let's get into some exercises here. Let's practice with these ideas. So the first things they ask us to do here is they gave us two little graphs, and they want us to do two things. Part A is find the x-intercepts. Part B, I gotta find the zeros of the function. Well, that's not really two different parts. That's kind of the same thing. Yeah, that's kind of the same thing. It's just a statement. I mean, literally it's sort of the same thing. So let's see, let me look at the first graph here. According to the first graph, what are the x-intercepts? So my x-intercept, this one over here on the left, I think we're counting by 2s according to this x-axis. So that's negative 4, 0. That would correspond to this right there. And the other one looks to me as though it should be 2, 0. But do notice that since they are x-intercepts, I'm supposed to express them as ordered pairs, as points. Now, what can I say about the zeros? They are sort of the same as the x-intercepts. They are very similar to the x-intercepts, except for the zeros. I don't use an ordered pair. I'm just going to say something like -4 and 2. Those are my zeros. Yeah? Okay, so for the next one, it looks to me as though I only have one x-intercept. And the x-intercept is -2, 0. Yeah? That's right there. So then what's the zero that corresponds here? Well, I guess that would be -2. Yeah? So it's sort of the same thing, x-intercept zeros, except that the zeros is just the solution to the equation. The x-intercepts, well, those are points. Okay, good. Let's think about the next little exercises here. So this part right here. So we want to use the discriminant to determine the type and number of solutions that exist. We do not want to find the solutions, so do not find the solutions. Just use the discriminant to tell me what type of solutions we have, complex or real, and how many solutions. 1, 2. And remember, the discriminant is this. I'll write the discriminant is b squared minus 4ac. Okay, so pause the video, take a couple of minutes, see what the discriminant has to say about these equations. Okay, so hopefully you already know what types of solutions and how many solutions each one of these equations has. So let me see, let me get going here. Let's compare answers. For the first one, I want to say this. X squared minus 3x minus 6 equals 0. First, notice that the first thing I had to do was set my equation equal to 0. Otherwise I cannot use the discriminant. Yeah. So, okay. So right now, what I know is that a is supposed to be the coefficient, the number that's in front of x squared. Well, that's 1. It's a 1 right there. Even though there's not an explicit 1, it's supposed to be 1. So 1. My b is the number in front, it's the coefficient of x, so that's -3. Just be careful, include the sign. And c is -6. Okay, so let me compute the discriminant. So that would say, so b squared minus 4ac, so that's -3 squared minus 4 times 1 times 6. Okay, that's 9. 9 minus 24. Yeah. 9 minus 24, that's going to be what? 15? -15. Sorry, -15. I gotta be careful with my signs. -15. Okay, so that is my discriminant. So what type of solutions do I have? Since my discriminant is negative, I'm going to have complex number solutions. It's going to be a complex conjugate pair. So here, for this exercise, we have complex conjugate pair. That's the type of answers that we're going to get for the first equation. We're going to get two complex numbers that are conjugates of each other. Why? Because my discriminant is negative. Okay, let me compute the next discriminant. And the next one's a little bit more straightforward. I know that a is equal to 2, b is equal to -1, c is equal to 4, and now I'm going to compute negative 1 squared minus 4 times 2 times 4. All right, so that becomes 1 minus minus 32. Yeah, so that's negative 31. All right, so that's my discriminant. So again, I'm gonna have complex conjugate pair. Hang on here. Did I make a mistake here? No, A is 2, B is negative 1, and C is 4. And B squared minus 4AC, it's negative, yeah? So complex conjugate pair. Okay, last one, let's see. So I'm not gonna say what A and B and C are. I know this is supposed to be negative 6 squared minus 4 times 1 times 9. So that's 36 minus 36. So 0. My discriminant is 0. What does that mean for the discriminant to be 0? If the discriminant is 0, sort of what's going on is this sort of graph. Your graph happens to touch the x-axis in only one point. So if the discriminant is 0, we have just one real number solution. Yeah. So then we're going to have one real solution. Okay, so that's what the discriminant helps us do. It helps us sort of determine the type of solution, complex versus real, and how many. Okay, next thing. So now we're supposed to be solving some of these equations, and they're going to specify the method by which you should solve each equation. So for the first, you're going to want to factor. For the second exercise, you're going to want to complete the square. And for the third exercise, you're going to use the quadratic formula. Okay, so give yourself a few minutes, pause this video, and try to solve these three equations using the method specified. Okay, so hopefully you got some solutions. Let's compare our methods of solving and our answers. So the first thing is I'm going to factor. I'm going to factor here. I'm going to factor this top equation. All right, there are a few methods of factoring. I'm going to do first what's called trial and error. All right, so literally trial and error I think is the easiest way to factor. You just open up some parentheses, equals 0, and now I gotta think that whatever goes in this position times whatever goes in this position, so this term times this term right here should give me 2x squared. Okay, well, I mean, I guess I have some choices. I could have something like 2x times x times 2x. I don't think it matters, so I'm gonna write the following. Yeah, so 2x times x, that's going to give me 2x squared. Good. And now, whatever goes in this position times whatever goes in that position right there, so this times that should result in negative 3. Okay, well, I still have some options. I guess I could do, I don't know, right now I'm just gonna try negative 3 plus 1. I don't know if this works. Let's try it. Let's see. So 2x times x, that's going to be 2x squared. That's good. And then 2x times 1, well, that would be 2x. And then negative 3 times x, that would be negative 3x. And then negative 3 times 1 is negative 3. do we get what we had to begin with? Well, 2x minus 3x is going to become negative x. So I think this works. Again, if it, for instance, if I had put the negative 3 over here where the 1 is, and put the 1 where the negative 3, then it wouldn't have worked. And then I would have had to change my guess a little bit until I get what I want. But right now what I did is just called trial and error. Okay, and so now I was able to factor my original expression on the left-hand side of this equation. So it's been factored. And now I have a product of two things. Something times something equals 0. So I'm going to set each one of the factors equal to 0. And this is due to the zero product property. So now I can say that 2x minus 3 equals 0. And x plus 1 equals 0. And then if I solve each one of these things, this guy should say x equals 3 halves. And this should say x equals negative 1. Yeah? So that's one way to solve this. I factor this. There's another method here. The other method, in order to factor this little trinomial here, one thing we could have done is the following. We could have said 2 times negative 3, that's negative 6. So where did I get this 2 and this negative 3? I looked at the coefficient of the quadratic term. I looked at the constant coefficient over here. So 2 times negative 3, that's negative 6. And now I gotta find factors of negative 6 that add up to negative 1. So I want to find factors of negative 6 that add up to negative 1. Where did I get negative 1? Well, the negative 1 comes from this coefficient here in the middle. Yeah, so I want to find numbers that multiply to negative 6 but add up to negative 1. Well, I think 2 and negative 3 are going to help, kind of be useful right now. Okay, and so then I'm going to rewrite original. I'm going to rewrite the original equation. It's going to look like this now. 2x squared plus 2x minus 3x minus 3 equals 0. So notice that it's the same equation. It's the exact same equation. 2x squared plus 2x minus 3x minus 3 equals 0. If I actually combine like terms, 2x minus 3x, that's going to give me negative x. So it's the same equation. Except that now the reason why I rewrote it is because I want to factor by grouping. Factor by grouping. Alright, so I'm going to kind of think of these two terms and group them together, and then think of these two terms and group them together. Yeah? So let me think of the first two terms on the leftmost. What do they have in common? I would say that they have in common 2x. So I'm going to factor out 2x. So 2x, and then what's left over is x plus 1. Because then if I distribute this 2x times x, it's 2x squared. 2x times 1, it's 2x. Now, what do the third and fourth terms have in common? The rightmost ones. I would say negative 3. So I'm going to factor out a negative 3. And this becomes x plus 1 as well. And now you can sort of think of this as having two parts. This and this part. And then ask yourself, what do these two parts have in common? What do these two terms have in common? I would say that they have in common this parenthesis x plus 1. Well, then I should be able to factor it out. And that's what it looks like if I factor out x plus 1. And notice that it's the same thing that I had up here when we did trial and error. It's x plus 1 times 2x minus 3. And so then now at this point, you could just kind of go back to that. Yeah, so this method works. This little method of multiplying the leading coefficient times the constant coefficient, and then finding factors that add up to the middle coefficient, rewriting your original equation, and factoring by grouping. All right, so again, it's so our answers here, our solutions are supposed to be 3/2 and x equals 1. I just show you two ways of factoring this little trinomial. One of them is by trial and error, and the other one is a little bit more involved, but it does the trick. All right, next example. Let's complete the square. Okay, in order to start completing the square, what I'm going to have to do is get all of the x's on one side and anything that doesn't have x on the other. So x squared minus 6x equals 10. That's what I'm going to start with. Okay, the next thing I'm going to do is I am going to look at the coefficient -6, and I'm going to think over here -6 divided by 2, that's -3, and then I'm going to square -3, that's 9. And so then that means that I'm going to add 9 to both sides of this equation. So I'm going to do this. X squared minus 6x plus 9 equals 10 plus 9. Yeah, why did I do that? So that this 3 terms on the left becomes a perfect square. This is a perfect square. Why is this a perfect square? Because think about factoring. Turns out that this factors as x minus 3 squared. Yeah, and now I have to solve for x. I gotta solve for x here. So then the next thing I'm going to do is I'm going to take a square root. But remember, if you take a square root, you have to remember that there's a plus and minus. So this is going to look like this. Okay. Also, if I can simplify the square root of 19, if I could, I would. But in this case, there's really not much to do here. The square root of 19 is a prime number. It's not divisible by anything other than itself and 1. So it stays like that. Okay, so then the last thing I'm going to do is add 3. So 3 plus minus square root of 19. Okay, so then I get two answers. One of them is x equals 3 plus the square root of 19. And the other answer is x equals 3 minus the square root of 19. Okay, so we solved that by completing the square. Last exercise here. Let's solve by using the quadratic formula. Okay, well, a is equal to 1, b is equal to 5, c is equal to 8. Okay, and the quadratic formula says that x is supposed to be equal to negative b plus or minus square root of b squared minus 4 times a times c over 2 times a. Okay, well in our case that's going to say negative 5 plus minus 5 squared minus 4 times 1 times 8 over 2 times 1. Okay, so let me continue here. So this is going to become negative 5 plus minus the square root. This is 25 minus 32 divided by 2. I'm looking at the discriminant. The discriminant is the thing inside of the square root, and I already know that that's going to be a negative number. And so then I'm going to have complex conjugate solutions. 25 minus 32, So it's negative 7. So this becomes negative 5 plus minus negative 7 over 2. Okay, so let's see, let me go down here. So then this is going to become negative 5 plus square root of 7i, this over 2, this over 2, and the other one is going to become negative 5 minus the square root of 7i and all of it over 2. And these are my complex conjugate solutions. Okay, so hopefully we agree on the answers here, and now you have several methods at your disposal. If factoring is possible, then factoring is probably the easiest case scenario. Completing the square is also pretty straightforward, and when everything else fails, then the quadratic formula is probably the tool to use. Good. So let's move on. Now we have 6 little things to solve here. 6 little exercises to solve. And you can use whatever method you choose. You can use whichever method you choose, whatever's easiest. And write your answers both in exact and approximate form when appropriate. I guess we gotta round to the nearest hundredth whenever we end up with decimals. So pause the video, and let's take a few minutes to solve this. There's supposed to be 6 here. You're only looking at 4 right now. So look at this 4, and then there's this other 2 down here. Yeah? Okay, so try to solve them. Pause the video, see if you can get answers for these 6 little equations. Okay, so hopefully you've gotten solutions for these equations. Let's solve them. I don't know, I'm gonna begin let's just begin from the top. Let's see. So this is going to become x squared plus 6x minus 7 equals 0. So I first have to set things equal to 0. Good. I think I can factor this. I think this factors as x plus 7 times x minus 1. I'm pretty sure that's the correct factoring there. You can always check if it's true. So x times x, that's x squared. X times negative 1, that would be negative x. And then plus 7x, well, that's going to give me 6x. And then 7 times negative 1 is negative 7. So I have answers x equals negative 7 and x equals 1. Okay, so I use factoring for that one. You could have used whatever other method though. The next one is easy because it's already factored. It's already factored for you. So all you have to do is set each one of the terms equal to 0. So 2x plus 3 equals 0 and 5x minus 2 equals 0. Well, that's going to say that x equals negative 3/2, and this is going to say that x equals 2/5. That one was pretty straightforward. Okay, let's see the next one. Let's move on to the next one. I think, I don't know if they progressively get harder. I don't know, we'll see. So for this one, what could I possibly do here? I guess I could complete the square. I could use the quadratic formula. Turns out I can also just factor here. I only have 2 terms. What do those 2 terms have in common? I would say x. So I'm going to factor out an x. Okay, and so then I have to set each one of my factors equal to 0. And well, this just says that x equals 0, and this over here would say that x equals negative 13. And those are my answers. Okay, let's see the next one. Let's think about the next one. So far I haven't touched any method other than factoring. The first three things were pretty much just solvable by just factoring. So factoring is a good, useful tool, and it's a good skill to keep on practicing, because you're going to be factoring in pre-calc, you're going to be factoring in calc 1, calc 2, so it's going to be definitely to your advantage to be able to factor well quickly. So let's see, can factoring save me right now in this part D? I think it can. I mean, because if you notice, each term is divisible by 5. So I should be able to factor out of 5. So let me factor out of 5 from everything. So that becomes x squared minus 6x plus 9. Yeah? And now I'm looking at the thing inside the parentheses. And I'm going to ask you, do you think it's factorable? Can you think of some numbers that multiply to positive 9 but add up to negative 6? And I think those couple of numbers would be negative 3 and negative 3. So this does factor. It factors as x minus 3 times x minus 3. Okay. So now I have a product of three things, 5 times x minus 3 times x minus 3 equals 0. I have to set all of the factors equal to 0. But think about this guy. This guy would say 5 equals 0. Well, that makes no sense. That's just a constant. So this guy is the one that's actually going to give me a solution here. So x minus 3 equals 0. And x minus 3 equals 0. Well, those together, then you say that x equals 3. Yeah. If you're thinking about multiplicity, yeah, there is this thing called multiplicity. The multiplicity is 2, and that means that we're going to bounce off of the x-axis, etc., etc. But that's a story for another time. Right now, the only solution is x equals 3. All right, the next one. So what can I do here? What can I do in this situation here? Can I factor? What can I possibly do here? Let's see. So I think there is a little bit of factoring that can happen. I know that both terms are divisible by 2. So I can factor out a 2. And this becomes x squared minus 5. Okay, so then I have a product of two things. This 2 times this x squared minus 5 equals 0. Well, 2 cannot be equal to 0. So I'm not going to set 2 equal to 0. It's kind of like what we had up here with 5. 5 doesn't make sense to set it equal to 0. So then what I'm going to do is I'm going to set this factor, x squared minus 5, equal to 0. And if you think about it, I guess I could use a quadratic formula. My a would be 1, my b would be 0, my c would be negative 5. I could go ahead and try to solve this, but it's much easier to just try to solve here kind of by hand. And so then x is equal to plus or minus square root of 5. So those are my two answers. Okay, and that's it for that one. That's it for that one. So those are my answers. I have that positive square root of 5 and negative square root of 5 are my answers. Although I did have to factor a little bit at the beginning. The last one's tricky. It's not even a quadratic equation. We're supposed to be solving quadratic equations here. This one's not quadratic. This one's a cubic. This one is x to the third. And so the quadratic formula doesn't even work here. The quadratic formula would be useless here. So then what should we do? I guess let's just give up. No, don't give up. let's try it. Let's try something. Actually, what's going to sort of help out here is we talked about it a little bit ago when we were factoring. It's this business of factor by grouping. We group the first two terms and we group the last two terms. So let's see if that helps us out here. Sorry, my computer's taking a little bit sweet time to load images. There we go. So let me think. I think here the trick is going to be factor by grouping. Okay, let's see how that helps us. So I'm gonna look at the first, at the left terms, and then I'm gonna look at the right terms. And okay, well, let's see. What do the left terms have in common? What do these left terms have in common? I would say x squared. They have x squared in common. So I'm gonna factor out an x squared from them. And this becomes 7x plus 1. Now, what do the third and fourth terms have in common? I would say that they have in common that they're negative, a negative 1. So I can factor out a negative 1, and this becomes 7x plus 1. Yeah, so we did a little bit of factor by grouping here. So I grouped the leftmost two terms, factored out an x squared from them. I grouped together the rightmost two terms, factored out a negative 1 from them, and this is where I'm at. And now you gotta think about this part as being one term and this other part as being one term, and I guess you gotta ask yourself, what do they have in common? I would say 7x plus 1. So let's factor it. Okay, and if I factor that out, then this becomes x squared minus 1. That's what's left over, and this is equal to 0 because I had x squared minus 1 right there. Okay, am I done? Well, kind of not, right? I need to set each one of my factors equal to 0. So I have to set this thing equal to 0. That says 7x plus 1 equals 0. That would say that x equals negative 1/7. So I have found one solution. But then I also have to set this factor equal to 0. This says that x squared minus 1 equals 0. Okay, and this is called a difference of squares, and it's factorable. It factors as this, x plus 1 times x minus 1. Or you could have just added 1 and then taken a square root, and well, then here we have answers. X equals negative 1 and x equals positive 1. So we have three answers: negative 1/7, negative 1, and positive 1. This one was a little tricky, but I'm sure you were able to persevere through it. All right, last little bit in this section. Let's talk about applications. Let's talk about some applications. So we have a little prompt here, and we're going to be talking about free fall time. All right, so the Burj Khalifa is it's a very tall building in the United Arab Emirates. It's 2,717 feet tall. How long would it take an object drop from the top to reach the ground? They tell us here that to use this formula, S of t equals 16t squared. T represents the time after the object has been dropped in seconds, and S of t is the distance that the object falls in feet. Yeah, so round to the nearest hundredth as necessary. And our question is, how long does it take the object to reach the ground? Yeah, so pause the video, see if you can answer it. Okay, so hopefully you know how long it took this object to fall from the top of this tower. Hopefully it didn't hit anybody down there. Let's see. So how do I even set this up? So let's see, t represents the amount of time in seconds. S of t represents the distance traveled, the distance that the object falls in feet. Well, they told me that the tower is supposed to be 2,717 feet tall. So right now, kind of what I gotta do is solve this equation. I gotta figure out the amount of time that it takes for the object to fall 2,717 feet. Okay, I think I can solve this. I'm gonna solve it start by dividing everything by 16. So let's see. 2717 divided by 16. Let me get the rounded version of that. 2717 divided by 16, we said. That's about 169.813. 169.813 equals t squared. Then I gotta take the square root of that, and there's going to be plus or minus 169.813. But think about what we're doing right now. We're trying to figure out time. And so is time going to be positive or negative? Does it make sense to have negative time? So I don't think so. So we're gonna just use the positive time. But to get in the habit of anytime that you're taking a square root solving an equation, there should be plus or minus. It's just that in this particular application, negative time makes no sense. So let's find the square root of this. So square root of 169.813. I'm just using my calculator over here on the side. I get something like 13 point, I'm supposed to round to the nearest hundredth to, so that's the second decimal place, 0312. So this is my tenths, this is my hundredths, so I'm just going to say that 13.03 seconds. All right, that's how long it takes this object to fall to the ground from the top of this tower. Okay, so hopefully we get the same answer here. Let's see, a couple more exercises here. I'm just gonna set them up for you. I'm gonna let you solve the equation on your own. Yeah, I'm just gonna help you set up the problem. So the length of a rectangular poster is 1 foot more than the width, and a diagonal of the poster is 5 feet. Find the length and the width. So the first thing is we gotta set up an equation. That's what I'll help you do. You'll solve the equation on your own. So the other one is one number is 5 greater than the other. The product of the numbers is 36. Find the numbers. So try to at least set them up. Take a couple of minutes, see if you can set up the equation that you're supposed to solve here. I'll let you solve the equation on your own though. I'm just gonna help you set up the equations. So let's see. We have a little poster. It's supposed to be rectangular. So I'm gonna call this the length. I'm gonna call this the width. So right now what they're telling me is that the length of the rectangular poster is 1 foot more than the width. So W plus 1. So the length is 1 foot more than the width. And the diagonal of this poster, so the diagonal, that's one diagonal right there. The diagonal is supposed to be 5 feet. Okay? So what can I do here? And by the way, do remember that this is supposed to be a 90-degree angle right here. Would you agree right now? So we have the length of the rectangular is more one than the width. That corresponds to that equation right there. And now I'm going to use the Pythagorean theorem to say the following, that L squared plus W squared is equal to 25. Yeah? Okay, and so then now let me put both of these things together to come up with the equation that you want to solve. Now what I'm going to do is I'm going to make a substitution. I'm going to make a little substitution here. Let me make this little line a little longer. So I'm going to say substitution. And I'm going to say the following. Look, I'm going to replace this L in this bottom equation, the one that the Pythagorean theorem one. I'm going to replace that L with W plus 1. So it's going to look like this. W plus 1 squared plus W squared equals 25. You see, now I have an equation that only involves W. So now I should be able to find the width. Once I find the width, then finding the length is just one plus the width. And let me take it one step further here. If you actually square this W plus 1, that becomes W squared plus 2W plus 1 plus W squared equals 25. So that becomes 2W squared plus 2W minus 24 equals 0. This is the equation you're going to have to solve. And I'll let you solve it on your own. I don't wanna deprive you from the pleasure of figuring out the width of this poster or the length. Okay, so hopefully we were able to at least come up with the equation and how to set up the problem. Last exercise. Again, for the last exercise, I'll only help you set up the equation. You'll solve it on your own. I'll say here, solve. Okay, so I have some numbers. One number is 5 greater than another, and the product is 36. I have to find the numbers. I do not know what these numbers are. I'm going to assume that they are, well, it doesn't matter. I shouldn't assume anything. I'm going to say N and M. Those are my numbers. Now, are they integers? Are they rationals? Are they reals? I guess it doesn't matter. Let's just say, call them numbers for now. One number is 5 greater than the other. So then that means this. It doesn't matter which one is greater than the other. So I'm going to say N is equal to 5 plus M. So then N is bigger. N is bigger by 5. And N times M equals 36. That's their product. So the product means this. Okay, so now again we're going to have to do some sort of substitution. And I'm going to replace this N right here, that N, with 5 plus M. Okay, and now it's just a matter of solving this. This is a quadratic now. The quadratic looks like this. 5M plus M squared equals 36. Or if you set it equal to 0, you should have M squared plus 5M minus 36 equals 0. Once you find the number M, you can find the number N by adding 5. So here you still need to solve. Okay, so that's it for this section. We've dealt with solving some quadratic equations. Thank you, and I'll see you in the next section.